black holes have always been a fascinating subject of scientific inquiry and popular culture. However, there are still many misconceptions about these enigmatic cosmic objects. One common question is whether there is a bottom to a black hole. In this video, we will delve into the nature of black holes and clarify some misconceptions surrounding them. The misleading diagrams often shown in popular science literature contribute to the misconception that black holes have a bottom. These diagrams depict the curvature of space-time around massive objects, such as stars and black holes. At first glance, the diagrams suggest that black holes are funnel-shaped objects with no end. However, this representation is an oversimplification due to the limitations of depicting three-dimensional objects in two-dimensional spaces. To understand the true nature of black holes, we must turn to the principles of general relativity. According to this theory, space-time is not a flat, two-dimensional grid but a complex and curved entity. Embedding diagrams, like the ones mentioned earlier, attempt to represent this curvature using a two-dimensional perspective. However, they do not accurately depict the true nature of space-time inside a black hole. In reality, black holes are not funnel-shaped objects floating in space and drying matter in only one direction. They have a spherical event horizon, which marks the point of no return. Inside this event horizon, gravity becomes incredibly strong, causing the laws of physics to break down. But outside the event horizon, the behavior of space-time is more familiar and resembles that of the rest of the universe. Therefore, a spaceship can maneuver under, over, or around a black hole as long as it stays outside the event horizon. The depiction of a spaceship being sucked into a black hole like a vacuum is a common misconception perpetuated by fiction. In truth, a spaceship could navigate near a black hole without being drawn into it, as long as it maintains a safe distance. Black holes do not have a bottom as commonly portrayed in illustrations. The concept of a bottom arises from the limitations of visual representation and the misunderstanding of the true nature of space-time inside a black hole. By understanding the principles of general relativity and the spherical shape of the event horizon, we can dispel the misconception that black holes have an infinite depth